I have a lot of things planned for today, like conditional loops and actually using the user input. So let's get into it. Here's the code from yesterday. There are a lot of things I wanted to get into but just didn't have the time for, so today's going to be quite a full episode. Now to introduce a conditional loop, let's start by printing a symbol a specified amount of times. To do this, I'll start by adding a section.data, and I'll write message, data bytes, and then the text, star symbol. Now to make a conditional loop, we'll have to use the jump instruction. And while we can jump to a line of code, it's easier if you just have a label for it. So let's create one. I'll make one here called for_loop. Now I'll start by writing the instructions that I want to loop. In this case, I want to print message. We've all done this before, so I'll just skip past it. Alright, there's the print instruction. Now up here, I want to type move ECX and then the number of times we want to loop. I'll just say 10 for now. Now let's call the for loop. So what do we do now? Because the ECX register is being overwritten here, we'll have to use the stack. I don't want to write push up here because call actually makes its own push instruction. So how about we use it down here? Let's type push ECX. You might not know why, but if I type down here pop into ECX, you might understand. Because it gets pushed onto the stack as it is, then gets overwritten, but then it gets overwritten again by what was on the stack. Now that we have that going, how do we loop? Let's go down here and type decrement ECX. In C, this would be ECX minus minus. And now I'll use the jump instruction, jump not 0. This checks if the mathematical operation from before ends up in the register becoming 0. Now if it isn't 0, we should jump to for loop, making this a loop. Now after assembling, linking, and now running it, we can input text, but this doesn't matter yet. And now we get 10 stars. There we go. But what if we want to take the user input, convert it to a number, and then use that number as the amount of times we will loop? Now in assembly, we don't just have an ASCII to integer function. What we can do though, is make one. Now to avoid a seg fault, I'll be writing mine down here, because every label does actually get executed unless jumped to or called. So let's type ASCII to integer. Now before this, I want to have a register to hold the string. As much as the register names seem random, they actually do have a meaning. The reason I used ECX for looping is because CX is actually the counting register. I want to use EDX, because DX actually stands for the data register. Now that we have that out of the way, let's type move EDX buffer. And I wanted to clarify something. Up here, I typed load effective address, ECX, the address of buffer. And I didn't really understand what this meant at first. So, I want to talk about it more so you can actually understand it more. Essentially, this instruction is the same as just moving ECX buffer. However, what you can do with load effective address that you can't do with move is you can index it further. For example, you can do buffer plus 1. This would be the same as buffer 1 in C. Simply put, load effective address takes the value of an address, while move just takes the direct value you put into it. Now that we have that out of the way, let's do call A2I. Now below here, let's type move ECX 0. I want ECX to hold the total number, so that's why I'm putting it to 0 first. Now what I want to do here is use a nested label. So I'll type dot top. Now when a label is prefixed by a full stop, it's inherited by the label before it. This means that it can only be called from that label. You'll understand in a bit why I'm doing this, but for now let's type move 0 extended. This means that the value we put into a register is changed to be as long as the register. If we put in a byte, then it will become 32 bits or 4 bytes. The way it does this is very simple. It just adds a bunch of zeros at the end. That's why it's called 0 extended. Now for this I'll just use EAX, and the value will be the byte at the address of EDX. Put simply, EAX is just the character we want to check the value of. Now in preparation for the next iteration of the loop, let's do increment EDX, so that at the next iteration we know what character to check. And now I want to compare EAX with the character 0. Now before I do anything with this comparison, I want to make a new nested label called .done. In here, all I'll do is return so that it's done, as the name implies. So what we want to do now is jump if less than .done. Now because the ASCII table is sorted quite reasonably, if it's less than 0, then it's probably not going to be a number, because just like how we count, it goes from 0 to 9. Similarly, let's now compare EAX with the character 9. So now we can jump if greater than .done. It got really warm in my room, so I took my hoodie off, but basically all this does is check if the value of the character can be turned into a number. Otherwise it just returns and goes away. Now let's subtract from EAX the character 0. If you haven't caught on yet, characters are actually read as numbers. So if I type 10, it would know that it's a new line character. If it was the character 0, and you subtract the character 0, it will end up in 0. If it's a 1, then obviously it turns into 1. Next, let's multiply ECX by 10. Because we've just confirmed that there is in fact a character after our current total, this means that our current total will have to be multiplied by 10. Hi, editing me here to clarify something. The reason I prefix the multiply statement with an I is because that's a signed operation. If you just type MUL, it won't work. Alright, so yeah. Next, let's finally actually add to ECX our number. And finally, to loop it back, let's do jump.top. There we have our very own ASCII to integer label. Well, now that we have that out of the way, let's finish this up. Oh, I didn't remove the +1. Remove that if you added that. Anyway, let's remove this too, because we already have our ECX set. And there we go. Now if we run this, and type 5 stars will be printed. There we go. And if we type 10 stars will be printed. But there's one teensy little issue. If we type an ASCII character that isn't a number, it goes a bit bad. Now to prevent this, I quickly want to make a new exit label. I'm calling it exit 0 because it returns 0. So let's do move EAX1, move EBX0, and now int 0x80. And now up here we can do compare ECX with 0. And now if it's equal to it, let's do exit 0. There we go. Now if I run this, and I type a non-number, it won't do anything. Now there's one thing I want to leave you with. I want to change the asterisk to an O, and now if I run this, and type 9, ladies and gentlemen, I just printed 9 circles. Have a great day. Subscribe, I guess.